So, hello everybody, I'm glad again to see you on my channel, and today we continue to solve exercise for fund companies. In my case, it's a Google. I really wanna get an offer from them, but to that we need to solve a lot of exercise and prepare for that companies. So today we will check the new exercise. It's called valid parentheses, and the type of complexity is easy. So I will try to explain it as easy as possible. I will add all details which you need to know about that algorithm, because the most important thing here is that to understand the algorithm. In what language you will implement this algorithm, it's not so important. So let's start. Let's try to understand the algorithm. So the main idea of this task is that we have open bracket of one type, and we must close it with a bracket with the same type. A bracket can contain another bracket inside it, but in that case, the nested bracket must close first, and then the outer one. So that's the most important idea here. So essentially, the algorithm works on the LIFO principle, so last in, first out, which means that the last element which we will put in our structure should be taken first. And this is because the last bracket we opened must be the first one we close. So that's the idea. And from this we can conclude that in order to solve this problem, we will need a stack, which is a data structure that works in this principle, LIFO principle, meaning that the last element we put into the stack will be first one we take out. So now let me show you an example of how the algorithm works on paper. So let's take a look here. So this is our first example, and initially we start from the first element. And what should we do? We need to check if this bracket is opening bracket. So we check if the first bracket is opening one, and we see that yeah, it does. So in our stack, we put a closing version. So we put something like this, and we go to the next element, to this element, and we check again if this bracket is opening one bracket. And in that case, this is not. So in that case, we need to check if in our stack, this element, the element which we put last inside our stack, is equal to this element. So we take over this element from our stack, and we compare it with this element where we now are located, let's say. And yes, they are equal, and in that case we consider that this part is valid because it's closed correctly. And we go to the next element, and again we use our condition, and we check if this bracket is opening one, and yes, it is. So in our stack we add closing version of this bracket, and we go to the next element. Again, we check if this bracket is opening one, and yes, it is again. So we add in our stack the next element, so the closing version of this bracket, and we go then to the next element, and we check if it's opening one, and no, it doesn't. So in that case, again, we need to compare if the last element, the last bracket which we add inside our stack is equal to this one. So we take over this bracket and compare with this one. And yes, they are equal, so we consider that this part is valid. And then we go to the next element, to this one, and again check if it's opening one bracket, and yeah, and no, it's not. So we compare it with the last element, which in our stack, we compare with that element. And yes, they are equal. Our stack is empty. So we can consider that all this array of these elements, 1, 2, 3, 4, 5, 6, is valid because all brackets are closed correctly. So that's the main idea. So in conclusion, we can say that we have two conditions which we need to use when we go through our elements. And the first condition is that we need to check if the bracket we are currently on is an opening one, and to push it closing version onto the stack. And the second condition is that if the bracket is not opening one, then we need to check whenever the last bracket we put on the stack equals the one we are currently on. And if it doesn't match, then it means that the bracket are closing incorrectly, and we can return false from our method. Yeah, because if one bracket is not closed correctly, it means that we can return false, so not all brackets are closed correctly. But actually it's not enough. Yeah, these two conditions are very important, but this is not enough for the case when we have an opening bracket that's never closed. So for this, after we go through all the elements of our elements, we need to check that the stack is empty, which will mean that every bracket found its matching pair. Yeah, so we can check this example in the right. So let's try to follow our rules. So first thing is we need to check if the first element is opening bracket, and yes, it is. It's an open one. So we put in our stack the closing version of this one and go to the next element. Again, we check if it's opening one bracket, and yes, it is. So we put the closing version inside our stack. And again, we go to the next element and we check if this element is opening one, and no, it doesn't. So we need to check if this one is equal to the last element which we put inside our stack, and we do this. So we check if this element is equal to this element. We take it from our stack, we compare, and yeah, it is. So we consider that this part is valid. And actually here we reached the end of our elements, so we don't have elements anymore. And we see that our stack is not empty, which means that actually somewhere here we have a bracket which was opened but never closed. So, which is not valid case, and in that situation we need to return false, yeah, because again we have a bracket which is not closed, so it's not valid. And for that case we will need to check, after we will go through all our elements, that stack is empty, because if it's empty it means that all open brackets found its matching version. Yeah, so that's the last condition. So that's the main idea of the algorithm, and now let's go and check the implementation. So let's start the implementation, and the first thing which we need to do is to create our stack where we will place the closing version of opened brackets. And let's do this. So deque character stack is equal to new deque. So don't pay attention that here we have the queue, because the queue is a data structure that use another principle, first in, first out. But actually in Java, this stack or this data structure also can be used like a stack. So this is a stack, And now what what we need to do? We want to go through all our elements from this string, but we cannot go through all elements in string. Yeah, we need to transform this in array of characters. So let's first of all create our for, which will help us to go through all elements. And let's transform our string in an array of characters. Okay, perfect. And now when we will start to iterate through all elements, we will start from the beginning. So we will start from first bracket. And the first thing which we want to do is to check if this bracket is opening one. So let's add some conditions. So if character is equal to a bracket of this type, then in our stack we need to add the closing version of this bracket. And let's do it for some other types of brackets. Okay, perfect. Now we'll need to add a condition when the current element is not a opening bracket, but is a closed bracket, closed version of bracket. And for that, how we already discussed, we will need to check if the current element, which is a closing version of a bracket, is equal to the last element which we added in our stack. So let's put here a condition. So why else? Because if it's not an open bracket, it means that it's closed one, and we need to put a condition. So if current element, which is closed version of a bracket, is not equal to the last element which we have added in our stack, that means that we need to return false, because brackets are not closed correctly, so we need to return false. And also here, let's add another condition. So what kind of condition? So we need to check if our stack is empty. And what does it mean? So let's imagine that our current bracket is of type closed, and we see that stack is empty, which means that the bracket is closed, but it wasn't opened, never. So again, this is not a valid situation, a valid version, and we also need to return false. And now the last thing which we need here to do, here is so when we will reach the end of our array, so when we will go through all our elements, we need to check if the stack is empty, because if it's not empty, it means that we closed the bracket, but we haven't found a match for that bracket. So we haven't found a closed version of it. So if it's empty, it will return false. It will return true, which means that everything is fine. But if it's not empty, it will return false, and it will mean that somewhere we have opened a bracket but it wasn't closed. So here is the implementation of this algorithm. I hope it was clear. And now let's check the complexity. So the time complexity for that algorithm is ON, and the space complexity is also ON. So thank you for the video. Sorry for for watching. I hope I help you better understand the task, the solution, and the algorithm, which is the most important thing. And we will see you in next video. Bye.